Okay, we're back. You'll remember from looking at ambiguous angles, and I might make a video of this later on, but we're trying to get you up to speed to where you left off at school. All right, so if angle A is acute, right, so all our references are in our textbook. They tell us whether or not we have no triangles, one triangle, two possible triangles when they're acute angles, and then when they're obtuse, whether or not we have no triangle or just simply one triangle. Right? These are important to determine before you go ahead and solve the whole triangle. Otherwise, you're doing work for no reason at all. Right? Excuse me. So, where you left off was, I believe, situational problems. There we go. They can be modeled by one or more obtuse triangles. So obtuse triangles, there's my key word. It's not an acute triangle, so that means we are probably going to run into all those need-to-know things up here of obtuse triangles. How many triangles do we have? Do we have a triangle at all? All right, so that's where we are. Situational problems. So we are going to just flip to this last one here. So when solving problems that involve trigonometry, you have some decisions to make. If you have a right angle triangle, a 90-degree triangle, you are going to use our SOHCAHTOA, Cox or Tix if you're on the grid, right? Primary trig ratio, sine, cosine, tan, right? To solve the missing sides and missing angles. Right? If you have an acute triangle, you will use either the sine law or the cosine law. Right? And you will have one answer. That's it. When you have an acute triangle is a triangle that has angles less than 90 degrees, right? They're acute, they're tiny. Okay. Obtuse triangles are triangles that are bigger than 90. One of the angles is bigger than 90. Okay. So we again can use sine law or cosine law, but we have to be careful because we have to determine, first off, do we actually have a triangle? Can we make that triangle? And if we can, how many triangles could we make given our side length? Right? So when you know the lengths of two sides and the measure of an angle that is not contained between the two sides, the case may be ambiguous. Right? So you will remember from a previous lesson where my suggestion was always in determining these is draw what I call the broken triangle. Right? So that this becomes your angle, this is your H over here, and this is your side B. Right? So we use our broken triangle to figure out whether or not this height here is going to be a right angle triangle, whether it's going to become an acute triangle, whether it's going to be an obtuse triangle, and you can always make reference to your textbook because I'm never going to ask you to remember all that information. Okay, I don't know what your teacher did, but when I taught this course, I would never make my students remember that. That's just craziness as far as I'm concerned. All right, so let's take a look at one example situation here. Real practical situation, right? So surveyors are flying around in a helicopter, right? So here they are, they're up in their little helicopter over here. Right? Maybe he's got some little, I don't know, little guy in here. The person who's flying on us, there he is sitting there. I think he's got a big, little smile on his face, maybe. And it's happy, he's flying. So he's flying around and he's looking at this lake, and this is Garibaldi Lake, which is in British Columbia. When the helicopter is 1,610 meters above the forest, the surveyor observes the angles of depression of 2 points on opposite shores of the lake measure 45 and 82 degrees. Well, what does that mean? Well, that means that he's flying, assumedly he's flying in kind of a straight line, not horizontal, right? He's not going up and down. Okay? So when he is above this lake, he is 1,610 meters above this lake down here. Right? Now, he notices two angles of depression on either side of the shore. So one on this side and one on the other side, right? Now, what is an angle of depression? An angle of depression is like when you're depressed, you walk around with your head down low because you're sad, right? So it's tilting her down. Elevation, we're looking up. Depression, we're looking down. So he notices that from one side, the angle of depression is 45 degrees, and that the angle of depression on the other side is 82 degrees, right? So from where he is, one side of the lake, 45 degree, and on the other side of the lake, 82 degrees, right? From there to there. So the idea here is that somehow we can figure out the width of the lake based on these two measurements. Right? Now, obviously, it would make a lot more sense just to swim across the lake with a big long tape measure. But that's pretty difficult, because if you've tried to hold a tape measure and swim with one hand, it doesn't work so well. Right? So let's take a look at how to solve this type of question now that we have some information. So I'm going to get rid of this. I'm going to pull this out. Okay, there we go. I'm going to move it back a little bit. Okay, there we go. All right. So, let's see, what do we have? So we have a picture here where, oh yeah, that's what I wanted to show you. Okay, so here's our guy. He's flying up in his helicopter here, right? There he is. Right? And we have this 45-degree angle, right? We have our lake, which is down here. And then we have this measurement of let's do 10 meters. So, in that triangle, right, we need to figure out our height. 90, right? Right angle triangle. So this angle of depression is 45 degrees, and if you remember a while back when we looked at parallel lines, we had something that was called Z angles, right? Where if this was 45 degrees, then this side was 45 degrees. Yeah? Well, that's exactly we extend their transversal, right? This is what we have. So that means that this angle in here must be 45 degrees because there's 45 degrees on that side of those parallel lines. Yeah? All right. So what we end up having here is we have two triangles. Right, so we need to solve this part of the triangle, then we need to solve this part of the triangle, right? Because he is 1,610 meters above when he takes his measurements, right? So, we're going to isolate our pictures, and let's see, I don't know if I can expand that, or, oh yeah, ooh, there we go, let's bring that down a little bit, a little bigger. A little more. Yeah, a little bit more. Okay, cool. Okay, so there's our 1610 and our 45. Can we slide this over a little bit? Or? There we go. Okay. All right. So we have two pictures here. I'll show you. Get see those. All right, so these are our two pictures that we're trying to solve. So you will remember that in our other picture there was also this angle here that was 82 degrees, right? Which is why inside here, right, for this part in here, this is where we got this other 82 degrees. And this is in your textbook as well. Okay, so those are our two angles. So in this triangle, we have 45 degrees, we have 90 degrees here. Means we can easily find out this other angle, 180 minus 90, that's 90, 9 is minus 45. Oh wait, it's 45 degrees, yeah? So we actually have a 45, 45, 90 triangle, which means we have 1 root 2 information, right? Have you done 45, 45, 90 degree triangles?
No.
Okay, maybe that's foundations 30. But when you look at the picture, what that's really doing is it's measuring from this side of the lake over to where he is floating above the forest, all right? That's not the measurement of the lake, right? In our other picture, or other part of the triangle, we have this side of the lake to where he's floating above the forest, right? So, in order to find the measurement of the lake, well, we take the long side and we subtract this little piece, and that remains, gives us this part in here, yeah? Okay. So let's see if we can move that up a little. Okay. So yeah, if you do not know 45, 45, 90 triangles are 1 root 2, if you don't know that special relationship, you can go ahead and use the information that you have. Let's just pull that down again for a second. A little more. All right, so we have this angle. We have an opposite that angle, right? We're trying to find this, the adjacent side, right? And we don't know what our hypotenuse is, right? So, sine, not going to help us, cosine, not going to help us, but we could use tangent, right, which is what they did in the text. So they wanted to find the tan of, so the tan of 45 degrees is equal to the opposite over the adjacent. So in this case, the opposite was 1610. Tan 45 is equal to A, right? So remember, we're going to cross multiply, right? So we're going to put a square around the thing that we're trying to find, right? And we're going to put a dot beside the things that we're going to dot beside the other thing, right? Keep it straight. So we end up having 1610 divided by the tan of 45, which is actually just 1, and that will equal side A. So side A is 1610 meters, right? And I already knew that because whatever this side is also the same. That's the 1-1 relationship, and this side would be 1610 times the square root of 2. 1 root 2, right? So now you learned a little bit about 45, 45, 90 degree triangles. All right, in this triangle here, I might as well go ahead and solve that one. So we look at 82 degrees. Well, its opposite side is this 1610. So the tan of 82 degrees is equal to 1610 divided by, well, they're calling this part in here side B. Right, so again, we're going to cross multiply. So we have b times the tan of 82 is equal to 1610. So b is 1610 divided by the tan of 82 degrees in this case. Now I don't know what the tan of 82 degrees is. I just know the tan of 45 off the top of my head. But we're just going to slide this thing up. And because it's already calculated for us. Okay, so there we go, the tan of 82 degrees, 1610, we get 226.27 degrees. So the width of the lake then will be 1610, that's the big long chunk, minus the little part, 226.27, and we get the width of the lake as being 1,383.73, or to the nearest meter, 1,384 meters. Yeah, does that make sense?
Yeah.
Questions?
No.
All right. So this is really where that case of having two triangles appears. Okay. So you're going to use the information that's given to you, draw the two triangles, and then solve each one to figure out those widths. Okay. So we're going to get you some practice questions. Let's move this out of the way. Oops, maybe not quite that far because we've got to be able to pull it back again. There we go. Yeah, that's good. Oh, hold it. I think you just lost it. Yeah. Okay. Let's go down to here. Nope, next page. Next bottom plug. There we go. All right, so for homework, let's see. You guys are going to do question. You want some practice, I think. What is this, 4.4? Yeah, 4.4. Okay, so you're going to do page 266. Page 266. Let me see what we got here. So, if you guys want to do some practice, page 266, you can do questions 1 to 7, number 10. Actually, you might as well do 10 to 12, I guess. You can do questions 17, 18, and 21 for some practice, and then you'll just self-correct in the back. All right. Our next unit is, I believe, on I don't know, I'm not sure what it is, but I think it's on distribution graphs and histograms and
Statistical reasoning.
statistical information, statistical reasoning, yeah. So we'll get some videos going with statistical reasoning. All right, so hopefully this gives you something to do during your home isolation. Enjoy. We'll see you again.